For this video, we're looking at a graph of velocity, and we're going to answer some of the same questions we answered analytically, but this time graphically. So, when is the particle moving to the right? Notice it says in bold letters, justify your answers. And I'm actually going to start with the justification because that tells me what I'm looking for in the graph. I know that something is moving to the right when the velocity with respect to time is greater than 0. So since this is a graph of velocity, I'm looking when this graph is greater than 0, so above the x-axis. And you may be able to see that it starts right there at time 0. So I'm going to say from 0 to 1. The particle is moving to the right. It's also, and it looks like it keeps going on forever here, so from 3 to infinity. And it's 1, 2, 3 if you can't see it on the video. When is the particle moving to the left? From 1 to 3. That's when the velocity with respect to time is less than 0. So below the x-axis from 1 to 3. On the interval from 0 to 4, when is the particle's position a maximum? Remember that velocity is the derivative of position, so we're asking when does position have a max. So imagine that this is your position graph and I'm just making up a random graph. The max would be right here. For us to get a max, the slope had to change from positive to negative. So that tells us that if you're looking on the graph of a derivative, you're looking for when it changes from above to below, positive to negative on velocity. So that happens on this graph at t equals 1. The graph was above and now it's below. So on the original graph, the slope had to be positive, then negative. So I'm going to say at t equals 1, there's a max, and I know that because v of t changed from positive to negative at that point. On the interval from 1 to 4, when is the particle's position a minimum? Well, you can draw a minimum, and if you look at the slope changes from negative to positive to get a min. So the graph of the derivative would have to be going from below to above, negative to positive. This would be position. This would be velocity. So the graph goes from below to above at t equals 3. So v of t changed from negative to positive. The next question says, when is the particle's acceleration positive? Now acceleration is the slope or the derivative of velocity. This is the graph of my velocity, so what this question is asking is, when is the slope of this graph positive? So when is this graph increasing? And that is happening from t equals 2 to infinity. So I'm going to write 2 to infinity. And I'm going to say v of t is increasing. Now, note that I'm using velocity for all of the justifications, and that's because this is the graph of velocity they've given to me. So I'm trying to stick with this for every justification. Okay, when is the particle's acceleration negative? Well, again, acceleration is the derivative of velocity. So when is the slope of this function negative? And that's from 0 to 2. So v of t is decreasing. Okay, when is the particle speeding up? So on the analytical example, we knew slowing down was when velocity and acceleration had opposing signs. Speeding up, if you imagine on the graph of velocity, if this is your time and this is your velocity, speeding up, you're going to head away from a velocity of 0. So if you look at it, your velocity is positive and the slope of the velocity is positive, or your velocity is negative and the slope of your velocity is negative. So what I'm looking for is for times when the graph is heading away from 0 as we go from left to right, slowing down. That would mean your graph is headed towards a velocity of 0. So what I have here, if we take the first interval from 0 to 1, my velocity is positive, but the graph is going down. So my acceleration is negative. Velocity positive, acceleration negative, that's slowing down. So from 0 to 1, and I'm going to say v of t is positive and decreasing, which is what's making my acceleration negative. From 1 to 2, it appears that my graph is headed away from a velocity of 0, so it should be speeding up. And you can say my velocity is negative and decreasing. The acceleration is also negative. So speeding up from 1 to 2. V of t is negative and decreasing. From 2 to 3, I'm headed towards a velocity of 0. So the particle should be slowing down. You can see that my velocity is negative, but my acceleration is positive. They have opposing signs. So from 2 to 3, and I can't use the same justification because it's just not true. It's the opposite. So v of t is negative and increasing. So the acceleration is positive. That leaves this last interval from 3 to infinity, and it's going away from a velocity of 0. So it's speeding up. My velocity is positive, and so is my acceleration. So 3 to infinity. So v of t is positive and increasing. And that's a quick look at a graph of velocity when we're thinking about motion.